guys. Do you guys have any questions before we begin? So we're gonna continue with the blood system that we left incompleted
Good.
yesterday.
Hey, good evening. I'm on my way from work home, so once I get home, I'ma log in, okay?
Okay, no problem. Thank you, Xiomara.
Cause I can't really hear through my phone. Thank you.
Okay, all right,
All
no
right.
problem. Remember that you have. Oh, okay, she's gone. All right, so let's continue with this chapter, very interesting chapter, which is blood. So we're gonna go back to the white blood cells and its divisions. So here we have it. Oops, it went too fast. White blood cells. Remember yesterday we were covering the types of white blood cells, that we have 5 types. We have a group of them that is called granulocytes, and another group that is called non-granulocytes. It is a little difficult to remember granulocytes, agranulocytes. So we better use non-granulocytes. So it's a lot easier. Even though this will not be asked in exams, granulocytes and agranulocytes, sometimes the types of white blood cells will be asked, particularly neutrophils, lymphocytes. They're very common because they are the one that causes bacterial infection and viral infections. And because we have all these conditions so often, so it is good that you learn it for you, for your own knowledge, and just in case, to apply this to your workplace when your patient arrives complaining about some fever, some cough, some sore throat, something like that. Okay, so let's see these white blood cells under the microscope. Remember, we're going to see the neutrophils, the eosinophils, the basophils, the lymphocytes, and the monocytes, because that's how they look under the microscope. Now, if you look here in this this picture, because this is a real slide from real blood work done. So if you see all these round red structures, they are red blood cells. So we have tons of them. But here is the neutrophils. That's how they look like. And if you look inside the cytoplasm, you see some rough stuff right there, some granules. That's what they call. This is the nucleus. This dark structure is the nucleus. It's like polymorphic nucleus. It has like 4 or 5 nucleus. So that's how we know them and we recognize them. So when we look at blood under the microscope, that's exactly what we look at, and that's exactly what we are trying to see. So this will be red blood cells, the ones that looks kind of red by themselves, and the large one right there is the neutrophils. This is white blood cells. So it says right here, these are the first to arrive at infection site. Remember that I mentioned it yesterday. As soon as we get attacked, invaded by bacteria, these neutrophils runs through that area, through the blood, through the cells. So they go there and they are prepared. Like, remember that I mentioned yesterday, the ambulance or the fire department or the police, they're gonna arrive to the scene or the accident or the crime, whatever the case may be. It's the same. So these cells attacks the microorganisms that invades, that trespasses our body. So to protect it, that's how they do it. Then they kill it, and then they eat it. Says right here, strong phagocytes. Remember that we talked about phagocytes when we were talking about medical terms, phago means to swallow, sites, cells that swallow something. So it is called actually eaters. So they eat. Remember yesterday I mentioned that there are some cells that eats whatever they kill. So this kills these microorganisms, these bacteria, and they eat it. It is the most abundant leukocyte within the white blood cells. So the 5 white blood cells types, neutrophils are the most abundant. We have between 54 to 62%. You're not going to be asked about that. Just know what the white blood cells are for. What is the defense mechanism? They are the one to protect us. Now, remember that I told you that if we find in a good blood test that the these neutrophils are elevated, meaning that they are beyond the normal ranges, that means that you have a bacterial infection. And that's when the doctor decides to prescribe you an antibiotic. Other than that, he or she is not going to give you no medications for this. So keep in mind that antibiotics are only used to kill bacteria, not just to kill any microorganism that is causing us an infection. That would be nice that only one medication eliminates every single bacteria, but that's every single microorganism that causes infection. Unfortunately, it's not the case. So we have for each microorganism, we're going to have a medication that we're going to give you. If I give you the wrong medication, it's not going to work. And the condition is just going to worsen. And the medication that I'm going to give you is going to cause you other damage to your body because it doesn't belong there. So that's how it works. So this will be the neutrophils. Let's go to the eosinophils. The eosinophils, now granulocytes, if you look at this picture, look at all these granules. This cytoplasm doesn't look like nice and soft like the red blood cell. No, they look like they have a bunch of pimples in there, if you will. So that's basically what it is. We have between 1 to 3% of them leukocytes. Remember, this is type of leukocytes. It says right here they are elevated during a parasitic infection or infestation or an allergic reaction. So either or, if you present with some symptoms of coughing, runny nose, a little fever, body ache, well, we assume that if we find these eosinophils elevated in your blood analysis, we're going to diagnose you with an allergic reaction. But if you're not presented with cough, fever, runny nose, scratchy throat, or any of the above, then we're going to diagnose you with parasites because you're going to tell us other story. Remember the itching on the anal canal, that will be one indication that you have parasites. If you start itching, you have parasites, most definitely. Of course, can be other things, but these are the ones that we are going to rule in most of the time. Then we have to do the examination of the area. If it is the anal canal, we have to see it to see if we encounter other invaders, other situations. And if we don't, we know already what it is. So then we give you an anti-parasitic medication, not an antibiotic, not an antiviral, not an anti-allergic. No, but if we find that you have an allergic reaction, we give you an anti-allergic. That's basically it. An anti-allergic medications or histamines is exactly what we're going to give you. So just for you to have an idea how they look like. And if you see, the cytoplasm looks like kind of very reddish. Whereas the prior one, it looks kind of pinky. So See the colors and all the stuff? Nobody's going to ask you this, just for you to know. Basophils. Remember, these are the phagocytes. These are the third one of the granulocytes. So what is it that this does besides eating all the debris from dead cells, dead microorganisms they eat? Remember, they are phagocytes. They also release histamines. Now, what is histamine? Histamine helps with an allergy reaction. Well, I'm sorry, this is the one that causes the allergic reaction. So we have to give you an antihistamine so we can kind of eliminate the histamines. Then these cells also produces heparin. This is the natural heparin inside our body. What is the purpose of heparin? They help with blood clotting. So they stop blood from clotting. They don't allow the blood to clot inside our arteries or veins. There are very little amount within the blood, see, 1%. So those will be the basophils. Let's talk about now the lymphocytes, which are the non-granulocytes group. Monocytes, agranulocytes. Oh, well, we start with the monocytes. Here they are. These are agranulocytes, non-granulocytes. It says that this is the largest of the white blood cells. Why? Because they eat. They are eaters. They eat everything that they encounter on its way. Dead cells, dead tissue, dead microorganisms, wastes, they eat everything. So that's basically what it is. Not much about this. Lymphocytes. Lymphocytes are very, very important. These are, I'm going to tell you a little story about this, but let's move to the end. If we find these elevated within the blood, when they analyze the blood, that means that you have a viral infection. Remember, viral infection. Look at this huge nucleus. It is huge. It covers almost the entire cell. So not a big issue, but these cells, remember, these cells are the only cells, the only microorganisms that invades our body that cannot be killed. So they survive forever. They stay in our body until we die. So some of these type of cells, really, really important cells, are the T cells and the B cells. These are B cells that are produced in different parts of the body. So B cells in the bone marrow, T cells in the thymus, this gland that is located right here in between the lungs. You don't need to know that. This is the lymphatic system. So just for you to know that lymphocytes are this type of white blood cells that kills viral infections, not kills, kind of protect us against these lymphocytes. Remember, these lymphocytes are the ones that surrender the virus. They put it in gel and they keep it locked. They lock them in. That's it. They don't kill them. Remember, I mentioned this yesterday. So that's basically what they do. Whereas a bacteria is killed by antibiotics, parasites are killed by and eliminated, eradicated from your body by antiparasitic medications. Allergies, they are eliminated with anti-allergic medications. But viral infections stays there forever. We just put it in prison. We just remove these unwanted intruders. We put it aside, some part of the body. But unfortunately, when our body becomes very weak, our immune system slows down, then these can appear again and cause us infections again. So that's why they are so dangerous. And that's what's so difficult to get rid of it. And these persons that are carriers or contains these viruses, they keep on passing these viruses to anyone that they have contact with. So that's basically what it is. Okay, so we are done with these 5 types of white blood cells. Remember, neutrophils, eosinophils, basophils, lymphocytes, monocytes. That's it. Any questions, once again, about these white blood cells? Remember, the take-home part of this is, or lesson, is that you need to know the function of each one of these blood cells. So red blood cells, they transport nutrients, but whatever is important, then the blood transports nutrients and everything our body needs to function. Red blood cells transport gases. Oxygen goes in and remove carbon dioxide. The white blood cells, the major function is to defend our body, is the defense mechanism. And we have 5 types of white blood cells, and each one of them has a different function. So that's what is important. Let's talk about platelets. Now, platelets, the only thing that you need to know is function. And what is the medical term that is known as? Because you can have thrombocytes or you can have the name of platelets. So you need to understand that platelets, thrombocytes means the same. Red blood cells, erythrocytes means the same. White blood cells, leukocytes means the same. So you don't mix them up, don't confuse them. So what is the function of the platelets or thrombocytes? They help with clot formation. I'm sorry, they prevent clot formation when it's not supposed to be. So these cells are the ones that promote clot formation when the body gets an injury. So let's say that you have a tissue injury inside our body. We don't know it. It was just a mild trauma, and you start bleeding inside. Well, if we start bleeding inside, can you imagine? That's not good because we're going to lose some blood. Well, platelets, what they do, they go to this blood vessel that is being injured, like this. So let's say that this is a blood vessel, a small blood vessel, of course. It has an injury, it's dripping, leaking some blood around here. Platelets that goes right here, goes everywhere. They immediately send a stimulus, send a information to all the platelets in the blood, and they come here and they cover this injury site. This cut, this hole, whatever you're gonna call where blood is seeping out, these platelets, they form a plug right there. So they don't allow the blood to keep on seeking outside the blood vessel. That's the function of the blood platelets. So having too many blood platelets, not good. Having less than normal, not good. If you have too many, you form blood clots. If you have too many, the blood becomes too thick. It's not going to be able to go around the blood vessels, passes through the heart, through all these blood vessels. It's not going to reach the very tiny capillaries. And if you have less than normal platelets, now your blood is going to be too thin. So now you're going to bleed, you're going to bruise very easily. And remember, when we said we're going to bleed internally. And that's why we develop all these bruises on our body if we have low or deficiency of platelets. So that's how these function. So know that the platelets are the clot cells or the clotting cells of our body. So that's basically what it is. They help. They are very important. Can you imagine during surgical procedure? During a surgical procedure, we're going to cut some tissues, some organs, something. So how is your body gonna heal fast if the platelets are less than normal? It's not gonna be. You're gonna be bleeding internally, so you're gonna die eventually. So we don't want that. We don't want a lawsuit, and we don't want you to die due to that problem. So if you look right here in this image, let's put image, oh, this is A, and this is B. If you look like the image A, all these little, oh, let me change colors because this color is kind of not seen. See, you see this group of little dots right here, these little dots right here, they are very, very small. So all these little dots right here, they are the platelets. So now when we look then under the microscope, this is how they look like. So that's basically what it is. The other ones are white blood cells. See, these are white blood cells, and this is the red blood cells. And these tiny ones that are piled up right here, well, this is not seen. Let's put it this way. So this one right here, see, and this little one right here, and this little one right here, and all those little dots right there, those are platelets. So here we have a pile, a group of them, that they get together because there is an injury on that area. So they go there to create a plug. This is like putting silicone on some areas that is leaking or is allowing something to pass through. So that's what these platelets do. They act like glue, like silicone, going there to the injured side, and they kind of, all of them piled together is called agglutination. Agglutination means all of the platelets gets together and they cover that injured area of the muscle or the blood vessel, whatever the case may be, and prevent that blood from seeping out the blood vessel. So that is exactly what happened. So that will be the platelets. So platelets, all the cells are important because they have different functions. So that's basically what it is. That will be platelets. Okay, so we talk about the solid part. Remember, blood is divided into parts, or it's made of two parts. Let's put it this way. Liquids, which is plasma, and solids, which are called these are red blood cells, white blood cells, and platelets, which are the form elements. These will be the solids. So let's talk about plasma, which is the liquids. We talk about the solids first. Now we're talking about that yellow color fluid that is separated from the blood when we centrifuge the blood. So that's basically what it is. So it says right here is a clear straw color, like a yellowish. It's the liquid portion of blood. Remember, we talk about the 55% of blood volume is made up by plasma. So 92% is water because the liquid part, everything else are solids. So it says right here, plasma transport nutrients, gases, hormones, vitamins, minerals, you name it. Everything. Helps regulate fluid and electrolyte balance, maintains the pH. So super important. It's not just that they transport whatever our body needs to survive or remove the wastes from things that have been consumed already, but blood controls, regulates, balances electrolytes, meaning all these chemicals inside our body, not the proteins. We're talking about everything that sodium, potassium, magnesium, chloride, zinc, whatever our body needs and have within the blood, it is controlled by the blood. Remember, this is the transport media of our body. This is like the train tracks, the streets, where all these cars, traffic passes through, transporting everything that is needed to move from one place to the next. So that's basically what it is. So for you, just understand the plasma is the liquid portion of blood after just the liquid portion of blood for the night. So that's basically what you mean. What is plasma? Oh, the liquid portion of blood. That's it. We know already the plasma is part of the blood. That, remember, this is the part that we are going to analyze. This is the part that we're gonna try to figure it out to see if you have too much of hormones or too little, or if you have too much of the gases, too much oxygen, little oxygen, too much carbon dioxide, little carbon dioxide. If you have normal amounts of vitamins, minerals, fats, sugar, everything. So that is what we do to figure it out what's bothering you, what's wrong with whatever symptoms or signs you presenting in our office or the emergency or just looking for medical care. So that's basically what it is. So this is the part that we analyze, not the red part. The red part is garbage. We don't need it anymore after centrifuge because whatever it was inside the red blood cells, the white blood cells, and the platelets, we have removed it already. So that's basically what it is. That's plasma. Okay, so we are done with the blood part, the components, what is the function of each one of these components of the blood. Now we're going to talk about blood types. So probably you know what is your blood type. I know which one is my blood type. It is very important to know your blood type because in case of an emergency, whether it's your emergency or a member of the family emergency, we might be donors. We might have to donate some blood so this blood can be transfused to the member of our family or to ourselves. Who knows? We never know how things are going to turn around. So knowing your blood type, many things. One, once again, blood donation. Remember, many people donate blood, but not in an emergency situation. You donate blood, and this blood will be utilized, will be processed, will be analyzed to, to see what type is it and to who we are going to transfuse this blood. Remember, you cannot transfuse blood that is a different type. So our body reacts bad if I transfer you or I transfuse you with a type of blood that's not compatible with yours. So that is like a death sentence. Instead of helping me out, you're killing me faster. So that's what is important about blood types, because if we need to transfuse this blood, we need to transfuse this blood to someone who has same type or it is compatible with your blood. Otherwise, we are going to kill the person immediately after we transfuse blood to someone else if they are not a match blood type wise. So that's what is important, blood types. So let's give a little more information about blood types. There is a group of blood that is called ABO. So It is a group system. It is a blood group system. So what is important about this? Well, once again, that we have four different types of blood. So we have type A, type B, see, A, B, AB, and O. These are the types of blood that we have. Now, yes, I know you're thinking, wow, but I'm A plus. Well, not talking about grade wise. I'm talking about blood type. Yes, you can have A plus, A negative, A positive. You can have B positive, B negative. You can have O positive, O negative. Or you can have A, B positive, A, B negative. Yes. So we're going to talk about that as well. So we are going to talk about these blood types, A, B, A, B, A, B, A, B, and O. And we're going to talk about them. This is called the ABO blood typing system, remember. Now, before we move uh, kind of further with this chapter, let's talk about what makes these types to be your type. Why do we have, what is it that I'm A plus or A positive? What is it that someone else is A, B positive? How is it that some other people are O negative or O positive? And so on and so forth. Because of these antigens, see, antigens and antibodies. We have antigens and antibodies within the cell. That's what it determines whether your blood type is positive or negative. It is A positive, A negative, B positive, B negative, AB positive, AB negative, or O positive or O negative. It has to be with antibodies and antigens within the cell. So we're going to move on and we are going to determine that. So the antigens are always located outside in the cell membrane. So let's say that I'm type A, my antigen A is going to be on the cell membrane, not within the cytoplasm. If if I have antigen B, so if I have antigen A, my type is A. If I have antigen B, my type is B. If I have antigen AB on the cell membrane, my type is AB. O is totally different. So that is what is important for us to understand these blood types. Sometimes you have at least one question for national certification, but I don't know which one is going to be. So once again, I'm going to go over some basics of blood types so you know which ones. I know a couple of them that you might have like 60, 70% of the time on exams. So your blood type depends on which antigen is on the surface of the cell membrane. So once again, you should know your blood type by now. So let's move on so we can determine all these blood types. Here we have antigens and antibodies. This is very important. Antigens, remember the antigens are outside within the cell membrane, and antigens, cell membrane, antibodies, they are inside the cell. They are in the cytoplasm. So that's what you need to understand. See, if you have blood, if your blood type is A, you have antigen A. See, if your blood type is B, you have antigen B. If your blood type is AB, it's because you have antigens A and B. We're gonna leave it there because O is a little more complicated. So let's work with this first. Now we also have to have antibodies. So if I'm type A, meaning I have antigen A, I have to have the opposite. I have to have an antibody B. Because if I have an antibody B, it's going to destroy my antigen A. So that's not good. So I wouldn't be able to survive. I wouldn't be able to be born. Actually, I will die as a fetus before. So that's how it works. So there are two type of antigens. Remember, not two types. There are two ways of defining whether you are type A or B or AB or O. But in this case, A, B, and AB. Remember, we have to have antigens on the surface of the cell. And that's what's gonna indicate what is the blood type that we have, antigens. Antibodies do not indicate what type of blood I have. Antibodies are located inside the cytoplasm, but they work on conjunction. So these antibodies are gonna prevent the destruction of my antigen. That's basically what it is. They defend me. But if I have the same antigen A and I have antibody A, they both cannot be together. So these will be killing each other. So that's why we have blood type B has antigen B, but then antibody has to be the opposite. Now think about here, AB. It has antigens A and B. So what antibodies should I have? None. Neither. Why? Because if I have antibody A, it's going to kill my A antigen. If I have B, it's going to kill my B antigen. So not good, right? So no antibodies. Now let's move to type O because it's very, very particular. We don't have an O antigen. Remember, antigens can be A, B, or AB. But we don't have O antigens. That's in excess. So on the surface of the cell, we're not going to see any antigens. So if we don't see antigens, we already know that you are O. That's it. It says right here, neither A nor B antigens because it's O, because we don't have O antigens. For that reason, when we see a cell and under the microscope, we don't see anything on this over the cell membrane. Why? Then we know already that this is O type. But then what are we going to see inside? Because we don't have anything outside, we have to have both antibodies A and antibodies B. So A and B is going to be inside. This AB is going to have A, B outside, nothing inside. This O type is going to have A, B inside, but nothing outside, zero, because there is nothing around here. So that's how blood types are determined. That's how we know which blood type you have. Once again, very important, because remember, if you go for a surgical procedure and we need blood to be transfused because you're going to be losing blood, we need to transfuse blood that it is your type. Because if it is not your type or something that matches your type, then you know what? Don't do the surgical procedure because you're going to die, because you are introducing something that is going to be toxic for my body, which is a blood that doesn't match my blood type. So that's how it works. So let's look at certain graphics, certain images right here, and we're going to see these over again so you can get a little better understanding how blood types works. So here we have, look at each of these images individually. So it says blood type, type A blood. See? So right here, we're going to have antigen A right here on the surface of the cell. So what we're going to have inside, see? Antibody B, antibody. These are going to be inside. That's how it is, which are these ones will be inside. So now I know that you have type A, antigen A, antibody B. Same goes for type B.
Does anybody hear me?
Yes.
What happened? Did his cut off? I don't know.
Maybe his computer again.
Okay, guys, sorry about this. Once again, this time was not my fault. It turns out that my computer started updating the software. Now it closed me. So I'm gonna continue. Can you guys hear me?
Yes.
Yeah.
Good. Yeah. Unfortunately, this time it wasn't my battery. It was the update that my computer did, and it took longer. Well, not much, but for me, it was like forever. Okay, so let's continue with this interesting chapter. We were talking about, once again, blood types. Remember, type A has antigens on the surface. So always think about that. If my type is A, then I will have right here on the surface of the cell A, the antigen A. But what do you say that we're going to have inside the cell? In the cytoplasm, we're going to have antibody B, which is this. These are the antibodies that are going to be inside. That makes my type to be A. The same goes for type B. On the outside, I'm going to have B antigen right here. Inside, I'm going to have right here all of these antibody B. Remember, antigen, antibody, totally different. So this is type B because the antigen B is on the surface of the cell membrane. Think about AB. This is type AB blood. It's going to have antigen A on the surface of the cell and antigen B on the surface of the cell. Because I have A and B, nothing is inside. You don't see any of this around here. You don't see anything. So nothing outside, nothing. So this is completely empty. No antibodies. Remember, if I have antibody A right here, it's going to kill my antigen A. If I have antibody B right here, it's going to kill my antibody B. So they do not go together. They don't get along. So that's basically what it is. This is like having a criminal and a policeman. They don't get along. Well, in the perfect world, right? So that's basically what it is. So A, B. So no antibodies. Same goes for O. Think about O. O doesn't have antigens. There is no antigens. So outside, nothing. We have the red blood cell right here. This is the red blood cell, but nothing on the outside. But yes, we have the antibody B on the inside and the antibody A on the inside. They are here. This is type O. So it's a little tricky, but most of the time, they don't ask on national certification, what is type A? How do you know that it's type A? But remember, type A has antigens on the surface. And the opposite to A is B. So it has inside B. And so on and so forth. So if I have A and B, I don't have anything inside because each one of these is going to kill the one that I have inside. If I have something inside, I'm not going to have anything outside. So once again, that's how it works. Let's look at this because these are the questions for exam. These will be 70% chances that you have it in your exam. Type O, remember, type O is known as the universal donor. Oh my God, donor. O's means O type. Donor. O. It has an O within. So that's it. That's how I know it. Universal donor. So they're going to ask you which of the following blood types is considered the universal donor. So this is the type of blood that it can give to any one of the types. So type of can be given to any type. If you are type A, you can receive O. If you are type B, you can receive O. If you are type AB, you can receive O. But wait a minute. Can all receive from all of them? No. All only receives from all. So that's how it works.
What about OB? What about OB negative?
Well, we're going to talk about that a little bit farther. Then we're going to talk about what is negative, what is positive. For now, it's just O. Later on, we're going to talk about why is O negative, what is O positive, what is AB positive, A positive, A negative, B positive, B negative. First, we're going to cover just the blood type. Then we're going to cover the other part. So that's basically what it is. So this is a question for exam. Remember, 70% of the time, this question comes on exams. They're going to ask you which of the following is considered universal donor. Remember, donor has the O within. So you know that is type O. Do, O. Ah, I get it. Well, that's how I learned it. That's how I remember forever. So I will never forget it because that's how I remember it. Now, type AB is the universal recipient. See, it's the opposite of donor. I donate blood. Let's say that I'm type O. My blood can be donated for any type. O, A, B, AB. That's it. It can be donated to any one of them. But then AB, which is the universal recipient, it can receive from all. This can donate. I can give blood to anyone, but I cannot receive from all of them, only from all. So if I'm type AB, I can receive from all of them because I'm recipient. I can receive from any type. See, it's totally different that I donate, that I give away my blood, and anyone, any type can receive it. That is donor. Now, I can accept. Now it's the opposite. I can accept blood from any type. So AB is considered universal recipient or receiver, if you will. So remember those things because these are the questions that you may have in your exam. That's what we go over all these to make sure that you don't miss anything. That if you have a question that you responded wrong, well, you have others that you know about it and you're gonna get it right. Okay, now we're gonna go to that question that you asked me already. RH blood group. Now, the RH, this is the one that give you this positive or this negative. So that's basically what it is. These are also antigens. So antigens are always on the surface of the cell membrane. We are talking about the red blood cells. Remember, our blood type is determined using the red blood cells, not the platelets, not the white blood cells. It's the red blood cells. Because if we go back here, we can see that these are the red blood cells. Now, besides having on the surface an antigen A, because this is type A, but if it is positive, you have to have here an antigen D, letter D, antigen D. So this antigen D is right here. So if I have antigen D right here, I'm going to be A positive. Well, what if I don't have it? Well, if I don't have the antigen D, then I'm A negative. Same goes here. This is type B. If I don't have the B right here, the antigen B, the antigen D, then I'm going to be B negative. But if I have it, it's going to be positive. The same goes for all types of blood. Now you understand this. This is the RH. R stands for rhesus. rhesus. So rhesus, this was a type of monkey that contains these antigens. So when they did evaluations, research, they found out that the monkeys have these. And that's what they have, certain positives and negatives. So then they related to the humans and found out that the humans also have these. That's why the monkeys are very similar to humans. So RH, once again, is the rhesus. This is the one that gives the negative or the positive to our blood type. And what is the name of that antigen? Antigen D. See? Antigen D. So here it says, or it reads, RH positive, presence of antigen D on the red blood cells membrane, which is the cell membrane. RH negative in general, they lack the RH antigen in the membrane of the red blood cells. So if within the membrane where the type, the antigen AB, or O is at, you don't see D, then you are negative. If you see the antigen of your blood type and you see D, then you are positive. So that's basically how this works. So it's not like any other way that we're gonna kind of determine how, what type of blood you have and whether it's positive or negative. So this is the way that we're gonna do it. So we're gonna evaluate it in this fashion. So once again, it's just for you to know how this works. Usually this RH is not asked except for the one question that we're gonna see in the lecture that we have next. So this is important and you will see why. Remember, the RH is not a key factor for me to receive your blood. What is important is the blood type. So I can receive, let's say that I'm O. Now, AB, let's put it that way, I can receive from anyone, whether it's A positive or A negative, B positive or B negative, O positive or O negative. It doesn't matter. It's not the RH that's going to determine whether my blood matches or not to get blood transfusion. It is the blood type. You cannot give me a blood type that is not compatible with mine. Forget about the RH. Whether it's positive or negative is not the key factor right here. It is the blood type that really counts. But we're going to see something where RH is crucial for something to develop or not develop. So you will see now what is the importance of RH. Our age group. So I'm going to be very, very simple. So think about it. These affects, the RH affects females. Remember, the RH affects females when they become pregnant. If you are RH A negative, B negative, AB negative, O negative, your blood type is negative, and you become pregnant, now you can be in a little trouble. If the person that you get impregnated from is positive. See, listen very carefully because that's what is explained right here. It's very important. If you are a female and you are type whatever, negative, and you become pregnant from a person that is positive, now you can be in a little trouble. Now your fetus can be in trouble. But we have the treatment for that. So that's the good thing. But if you don't know, if you don't follow this prenatal care, meaning that you go visit your obstetrician regularly to see how the fetus is developing and all that stuff and how you doing, so then we're going to be in trouble. Remember, every single time that a female becomes pregnant, we do a bunch of tests. One of them, if we don't have blood type, we must have the blood type because we need to know whether you are negative or positive. Whether we don't care about your husband, we don't care about the boyfriend, we don't care about the person that impregnated you. That's not what I'm talking about here. What I'm talking about here is that you are negative. If you are negative, that is a problem. So then we do an evaluation. Females that becomes pregnant, they go to the doctor, they do certain evaluations, and we check blood type. And when we see your blood type and we see your RH and you are positive, we are not worried about anything. If you're positive, we don't worry. Even though if you're the father of your child is negative, we don't care. We care about females because you are the one who are developing the fetus inside. So you are the one who's going to get in, not you, but the baby is the one who's going to get in trouble. So the female has to be negative, nothing else. Are you guys understanding this? So our age factors really matters, but with females when they become pregnant. If a female become pregnant, it is negative. It is type blood negative. On the father of the child, it is positive. This positive is gonna clamp, is gonna collide with the negative that the mother has. So now what's gonna happen? Then it's gonna kill the red blood cells, and the child is not gonna develop. You're gonna develop miscarriage. You're gonna develop miscarriage. That is 100%. So some mothers, if you don't go to the doctor, if you're not evaluated by follow-up by the doctor during the prenatal care, what's gonna happen? Then you might be negative, and then you get impregnated with someone who is positive. Then in the first weeks of pregnancy, maybe a month or so, you're gonna have a miscarriage. And if you go do it again, you're gonna have another miscarriage and another miscarriage as many times as you intended. Because your body already developed a resistance against this negative, this positive type of blood. So they don't get along. Remember, this is like having antigen A and antibody A. They kill each other. So you should not have, you should have the opposite. But here you are negative. The husband, in order for you not to have a problem, the husband has to be negative. RH negative, then you're not going to have problems. But if he's positive, you're going to have problems. That's what you have to be evaluated by a doctor. If a doctor evaluates you and checks that you are negative, the doctor is going to give you a medication, an injection before the baby is born and after the baby is born. That medication is called Rogaine. I don't know if some of you have received this. If you receive a medication when you were pregnant, an injection, not for any infection or anything else, but to prevent the fetus from dying, then it's because you are negative. If you're negative and you became pregnant and the father of the child turns to be positive, then they have to give you this medication. They have to give you this injection. It is like 24 weeks before the pregnancy, you can give that. And right after you deliver the baby, I had to give the medication again. So that's basically what it is. Otherwise, the fetus is gonna die because the blood of the fetus, that it is the blood of the mother, is gonna mix with the blood of the father when you are born. But this is not the case in that moment because you are not gonna be able to survive because that blood is going to be mixed and the fetus is gonna die. So that's what's going on. So that's explaining all these because here they have too many technical terms, and I don't want to go over every single term, technical term. So I just explaining to you what is the problem with our age. Only affects females, and you have to be negative. Other than that, nothing is gonna happen. Remember, if you females are positive, it doesn't matter what our age is the father of the child. It doesn't matter. Only matters when the females are negative, period. Here we have the medication that the females receive when they are pregnant. See, Rogaine. And that has to be given like with the first 24 weeks of pregnancy and after birth. Otherwise, to prevent fetal hemolytic anemia. Hemolytic anemia, hemo, blood, lytic destruction. So it's going to destroy red blood cells. And if you destroy your red blood cells in your child and your fetus, well, it's going to die because it's not going to have red blood cells. It's not going to have oxygen. So they're going to die. So that's basically how it's done. So that is called erythroblastosis fetalis or hemolytic disease of the newborn. See, there is no way, not even a miracle can save you. The baby will never be born. They will die in the first weeks of pregnancy. Once again, you will develop a miscarriage. That is 100%. Remember, these antibodies from the side of the father is going to kill the antigens from the side of the fetus. So for that reason, not good. So that's the condition called erythroblastosis fetalis. So it is a condition where the new cells, the baby cells or the red blood cells are destroyed. You don't even let them mature. Remember that the red blood cells last up to 120 days. So as soon as the red blood cells are produced, they are destroyed. So you don't even have red blood cells. So that's basically what it is. So that's why it's so important to go to the doctor, get the prenatal care, know what type of blood you have. You don't have to select who you're gonna marry with. Oh my God, now I have to get someone who got to be, if I'm negative, they have to be negative. No, it's just that you have to go to the doctor and the doctor is going to evaluate you and the doctor is going to give you medication 24 weeks after pregnancy and when the child's born. That's it. Then you save your child and you save your pregnancy. And then you have to do it from then on. Every single time that you become pregnant from the same person that is positive, you have to get this medication again. Any questions about this? See, it is called RH incompatibility. Now, remember, we have blood type incompatibility. That means that you are transfusing blood that is not matching my type of blood. But here we're talking about RH. And we're talking about females that are negative. Remember, if you are positive, do not worry. If your blood type is positive, regardless of what blood type you have, you have no problems as if you are negative. So right here, see the first Rh negative female with an Rh positive fetus, meaning because the Rh positive came from the father, not from you. So that's basically what it is. Here we have the antigen D. Because you're negative, you don't have it, but the fetus have it. So here, see, you don't have the antigen D because you're negative, but the father has because it's positive. Because if your fetus is positive, it's because the father is positive. Because you're negative. So that's basically what it is. So the female becomes, see, sensitized to antibodies against the Rh negative. So the antibodies from the father's side is going to attack the antibodies from the mother. Not the mother directly, but the blood that the baby is living from, or it is receiving all the nutrients, is the mother's blood. But this time is the fetus that has it. So the fetus cells are going to be killed, red blood cells. So right here it says that in the next Rh positive pregnancy, maternal antibodies attack fetal red blood cells. See? So that's basically how it is. So once again, there is one thing that I think that I didn't actually mention correctly. So the first pregnancy, you're not going to have a problem. You're going to have your baby. That was one of the things that I almost, I make a mistake, I guess, or I omitted. So the first pregnancy is fine. You're going to have your baby. From the first pregnancy on, if you weren't treated with Rogan, 28 weeks during the pregnancy and after birth, now for the second, third, fourth pregnancies, you're not going to be able to have babies. Because it's during the childbirth that you are going to have this mix of antibodies and antigens from the fetus, from the positive and negative of the mother. So it will be your second, third, and on pregnancy. The first pregnancy is going to be fine. But if you're not treated with Rogan during the first pregnancy, during the pregnancy and after the pregnancy, you won't be able to have babies anymore. Not from the negative, from a positive person. So that was something that I was leaving off right here. So the first one, you have it. So that's so important that you need to be treated during the first pregnancy, because otherwise you're not going to be able to have babies for the second one and the third one and the fourth one, if it is from a positive father. So that's how it works. Any questions? No. Okay, moving on. So let's talk about anemias. We are not going to go every single type of anemias in detail. We're just going to mention them and what causes them. So there is one type of anemia that usually is being asked in exams. So remember, anemia is when you have problems with oxygen capacity, meaning your red blood cells, which contains hemoglobin, we discussed this yesterday, you don't have enough red blood cells, or the red blood cells are enough, but they are immature, so they don't carry hemoglobin. Only mature cells, red blood cells, carries hemoglobin. So hemoglobin is the one that transports oxygen inside the cells and remove carbon dioxide. So if you don't have enough oxygen, you're gonna develop anemia because your hemoglobin is low. That's what we measure hemoglobin levels. So remember, hemoglobin is a question that is asked in exams. So hemoglobin is a protein. And what is the function of hemoglobin? Transport oxygen inside every single cell of our body and remove carbon dioxide. That's the function. So let's talk about types of anemias, just for you to know. So we have first, right here, aplastic anemia. So aplastic anemia is a chemicals or radiation that causes that. See, that's why when you're gonna get x-rays or things like that, they protect you with an apron that is made of lead. So doesn't allow to pass radiation to certain areas, particularly the reproductive system, because we have to protect the reproductive system. It's not anything else that we protect. Because if we damage the ovaries, the eggs, the testicles, the sperm, then they are damaged. So you're going to pass this condition, or you're not going to be able to have babies, or you're going to have babies that are deformed. So that's aplastic anemia. So that will be damage to the bone marrow. Why to the bone marrow? Because this is the one that produces red blood cells, white blood cells, and platelets. And white and red blood cells that are the majority of the cells of the blood, they're going to be damaged because they are producing the red bone marrow. If you are exposed to radiation or some chemicals like these chemicals that are used for cancer, chemotherapy, they are very dangerous. They protect you from one thing, yes, but they damage other things. That causes anemia. That's what these people has to have blood transfusion. Hemolytic anemia, chemicals again. Chemicals are, see, when you, chemicals means anything that you are exposed to it. Medications, overdose of medications. So it destroys the red blood cells. Now, these chemicals don't destroy the red bone marrow. No, they destroy just the red blood cells. That is called hemolytic, blood-lytic destruction. So destruction of the red blood cells, which causes anemia. Aplastic, on the other hand, is destruction of the red bone marrow, which causes anemia, because now not only you don't have white blood cells and platelets, but you don't have red blood cells. It damages everything. Iron deficiency anemia, very common anemia. Probably you have been diagnosed with iron deficiency. That means that you lack iron, this mineral that helps, that assists hemoglobin to be produced. This is the mineral that makes up hemoglobin, the one that gives the color of the blood. So it says right here, dietary lack of iron. So usually this is a common question for exam, because they're going to ask you which type of anemia is due to lack of iron. Iron deficiency anemia. Or they're not going to give you like dietary lack of iron. It's due to dietary deficiency or something. So then you know that if it is because you are not including this iron within your diet, then you're gonna develop iron deficiency anemia. Females are more prone to develop this because of these hormonal changes that they go through. So that's basically what it is. So if you're gonna have this type of anemia, this is gonna be one of them. iron deficiency anemia because it's due to the lack of iron in your diet. It says right here, hemoglobin deficiency. So this is when they check your hemoglobin levels and then you see that your hemoglobin levels are low. So what are your hemoglobin levels? Let's talk about them because then you know when you're anemic, when you're not. So let's see this. Let's do this. So hemoglobin levels, hemoglobin, this is hemoglobin equal. It goes from 12 to 18. In females goes from 11.5 to 16. See, females have less hemoglobin levels, so less red blood cells. For that reason, your hemoglobin levels are measured differently. This is for males. This is for females. These are the signs for males and females. See, males, an arrow on top, females, an arrow down. So your hemoglobin levels needs to be between 11.5 and 16 in females, 12 to 18 in males. If you go below 11.5 as a female, then you have, well, all depends on what is it that, causes either of these types of anemias, of course. But if it is due to lack of iron deficiency, now this is the one that applies. Hemoglobin. So it will be iron deficiency anemia. You should not have more than, oh, I have lots of hemoglobin. Wow, I'm so good. You have more than 16. That's not good either. You can't have too much because that means that you have too many red blood cells. Not good. Remember, we have to be balanced. So hemoglobin is a way of measuring your iron deficiency anemia because it is running in your blood. So we are going to check that out. So this is very common in females and elderly patients because they are malnutritious. Iron deficiency. There is another type of anemia that is called pernicious anemia. But this is nothing else than the lack of deficiency of vitamin 12. See? Then you heard about sickle cell anemia and thalassemia. Well, thalassemia, you never heard about that, but probably sickle cell. Usually these are not questions asked, but sickle cell are defective cells. So the red blood cells are shaped differently. They are not round. They look like a sickle cell, like a half a moon, like this. So there is no center. There is no space where to put the hemoglobin. It's not. So because it lacks this part, then you don't have hemoglobin. But that is an inherited condition. Remember, that is an inherited condition. If your parents have a sickle cell, then some of you are going to develop sickle cell anemia. That requires blood transfusion for you to survive. So it's very serious. Of course, there are different types of sickle cell anemia. There is one that is called the tray, and another one is that you have complete sickle cell anemia. Complete sickle cell anemia is the worst one. The tray, nothing. It's just that you have a tray, kind of a little something, but nothing serious. So that is anemia. So remember, iron deficiency anemia, it is due to lack of iron in your diet. So remember that because that might be a good question for exams. Got it? Any questions about blood types or anemias? Okay. Let's talk about conditions due to problems, disease of the blood. Just for you to know, because it is important. Leukemia. There are different types of leukemia. So leukemia is cancer in the white blood cells. Leuco, white, emia, blood. So the white blood cells in the blood. So that's basically what it is. So don't kill too much trying to understand this. It's just know that if a person has leukemia, it's because they have problems with the white blood cells. So usually you have too many white blood cells. It's excess in white blood cells that causes this. Someone else might think otherwise, right? Wow, I have excess of white blood cells. That means that I have all these defense mechanism. It's going to protect me from everything. No, remember, having too much of something or too little of something is not good. We have to be balanced. Homeostasis, homeostasis, homeostasis all the time. So that's basically what it is. Now, there are two types of leukemia. One that happens to children, and one that happens to adults. Oh, yeah. This is like diabetes. Diabetes that you were born with, type 1, diabetes that you acquire, type 2, due to your diet. See, same goes here. This damage might be inherited, usually. So leukemias. Who develop leukemias? Males. Males are the ones that develops leukemia. They have problems with the lymphocytes because you develop cancer of the lymphocytes. These are cells, white blood cells. Remember, the ones that if they are increased is because you have a viral infection. So there are some type of white blood cells that causes this. So that's it. So you don't have to kill yourself learning all this, but because I have a lymphoid leukemia and myeloid leukemia. So that is what you need to understand. So this lymphoid, because it's the lymph nodes that produces these cells. Myeloid, because myeloid is bone marrow, and this is produced in the bone marrow. So damage to the bone marrow cells can cause leukemia, make the bone, the bone red bone marrow to produce too many white blood cells. But in a person who is an adult, the other one, this person was born with lymphoid leukemia because it appears when you're a child. So that's basically what it is. So leukemia in general, that's the only thing that you need to know, is that this is a cancer in the blood due to excess of white blood cells or lymphocytes. Remember, this particular type is not the neutrophils, it's not the eosinophils, it's not the basophils, it's not the monocytes, it is the lymphocytes. That's it. Can be treated with chemotherapy, other type of drugs that are used for these type of conditions, or remember the stem cells transplant, bone marrow. We mentioned this when we were talking about hematopoiesis, the production of red blood cells, white blood cells, and platelets. So that's basically what it is. Technology has advanced a lot. So someone who was born with a leukemia, we will know immediately after the baby start developing that the person has that, because it's going to present with anemia in a short period of time in the first years of life. So then we're going to check the bone marrow and we're going to encounter that this person has, well, we do a blood test and we know that they have an excess. When we say an excess, it's a lot. So that's basically it's like millions of white blood cells. So that's basically what it is. That's leukemia. That's it. This is the most common cause. Remember, we talk about anemias, which is a very common topic asked. Anemia is the most common condition of blood. Anemia, because almost every human being develops anemia of one type on their lifestyle. So that's basically what it is. All right, so we're done with this with chapter. Any questions? Okay, so you don't have no questions, which is not good, right? Okay, let's then switch chapters. The respiratory system. Now remember, we kind of touched bases on the respiratory system. Let me see. Yeah, we still have some time. So before break, the respiratory system, let's do a good introduction of the respiratory system. We're going to talk about the structures, remember anatomy and physiology, the function of each of these structures within the respiratory system. So these chapters, when we talk about these systems, it is easy to know what is it that we are going to be talking about, right? When we said the blood, well, we heard about the blood. It's just that we didn't know all the intrinsics within the blood. The respiratory system, well, we know that now we are talking about breathing in and out and all the structures that do this function. In certain conditions that happens when these structures do not function properly. So that's the purpose of anatomy and physiology. Knowing the structures, anatomy. See, I've been repeating this so many times. Anatomy means structures. Physiology means functions. Because these are questions for exam. What is anatomy? Oh, the structures. What is physiology? The function of the structures of our body. So if we would talk about cells, they are structures. Tissues, they are structures. Organ, they are structures. System, they are structures. The entire body is structure. Function, what these structures do or do not do. They function or malfunction. Because in medicine, what we try to do is to investigate whether these structures, which structure is not functioning properly, so we can correct the problem. So we can fix the problem. That is the key with this type of science, the health science. To get to know the body, it is structures, functions, and then how to correct them if something happened, because it always happens, right? That's what we go to the doctor all the time. Because there are many things that happens to our body. If it happens to the respiratory system, we need to know which part, which structure, where is located this structure, what it does, so we can correct it, so we can fix it, so we can put you back to normal or almost normal. We're going to try to fix something. So that's basically the respiratory system. Remember, respiratory system, we're going to talk about the functions, but for now, let's talk about the structures. So if you can see, we have here this image of the lungs. But the respiratory system is not just the lungs. We have other structures. Remember, we need some other structures from other systems to make this particular system work. So here we have parts of the digestive system, the mouth, the nose, because the mouth, we can breathe to the mouth. But we're going to have a common place, which is the pharynx that we call the throat. So that's basically what it is. So we have here the lungs without air and the lungs with air. Remember, the blue part is that you are breathing in. So here we are breathing in, we are putting air on. We are putting air right here, entering air from the atmosphere, from the outside, from the environment, enter that air through the nose, particularly. Then it goes all the way to the back of the throat, then to the pharynx, not that to the larynx, not the pharynx, because that's for food and liquids, to the larynx, to the trachea, to the bronchi, right and left, to the bronchioles, the branches, to the lungs. Then we're going to talk about some other very tiny structures that are called air sacs, alveoli, when actually this gas exchange is going to happen. So we know the location. They are located in the chest cavity, the thoracic cavity. That's when we have the lungs. That in conjunction with the heart, they're going to do the work of removing and providing oxygen and carbon dioxide. So that's how it works. So let's see more structures a little more in detail in this image, this diagram, if you will. So here we have, let's use green because everything else we can see it. So here we have the nose. So the air enters through the nose. Let's say the mouth, we are not mouth breathers, so we use mostly the nose, passes through all these structures, goes right here to the back of the mouth, which is the throat right here. Then the air passes through this place, which is called the pharynx, and then go all the way to the trachea, to the lungs, to all these structures that we're going to find, which are the passageways. We're not going to talk about every single detail of the respiratory system. We're going to talk about the major structures, their functions. So that's basically what it is. So, talk about these structures that are going to be the tracks, the passageway for air. And what happens when these structures are not doing their job? Well, we're not going to be able to breathe. We're going to have some issues breathing. So that's not good, right? Okay. Functions. So as I walk you through already these structures, these are the pathways or air passages. And what is the pathways or air passages? Well, body passes air, right? Remember, it's not oxygen. The oxygen goes inside the air. We breathe air, not oxygen. The oxygen is within the air, so we breathe air. So it is called an air distributor. So it takes air from the atmosphere and it's going to pass it through all these pathways or passages, air passages, until it reaches the place when you're going to do gas exchange. What is gas exchange? It ensures that oxygen is supplied and carbon dioxide is removed from the body. We're going to supply oxygen to the body and we're going to remove carbon dioxide, which is the waste of oxygen. After oxygen has been consumed, the end product is going to be CO2, carbon dioxide. So that's basically what it is. So we're going to have different functions, see? Breathing in, breathing out. These are the layman terms. Can you breathe in? That's what we tell the patients. Can you breathe out? But also breathing in means inspiration, inspire. So inspire, expire. See? Taking air in, inspiration, taking air out, expiration. So we need to know those terms. They are very important. Inspiration, inhalation, exhalation. You inhale, you exhale. See, these are other terms that we use. When we command the patients to do something, to breathe in, we tell them to breathe in, take air in. Can you breathe in as much as take air in, breathe out, let it out. We don't tell the patient to inhale and exhale because usually they're not going to understand these terms. So again, but you got to be familiar with these terms because you are in the medical. So inspiration, inhalation, taking in, see, in. Expiration, exhalation. So we know exactly what they're talking about. So these are exactly the functions of the respiratory system. Taking air in and removing the oxygen, putting it inside and delivering oxygen and then removing carbon dioxide. Simple. Gas exchange. Let's divide the respiratory system organs in parts. So we have the upper respiratory tract and the lower respiratory tract. This is very important for us. As medical providers, we need to know where exactly the conditions are happening. And in order for us to know where the conditions are happening with this respiratory tract, we need to locate the organ. And to locate the organ, we need to have directions. Remember the first chapter, medical terminology, for those who took medical terminology, directionals, very important because we need to know exactly. It's like the navigation system. It's going to be telling us every single step of the way as we are driving. And it's telling us, exit top, there is this right here. We are close to the area. We are right there. So it's telling us how long it's going to take. Here, we are going to find out the track. It is location. So what makes up the upper respiratory system? Anything that it is above the trachea. See? This part right here is called the upper respiratory system. The nose, the throat, the pharynx, the larynx, right here. Then that will be the upper part. That's it. So if you have something that is affecting you, your nose, your throat, or your voice box, which is the larynx, so then immediately we know that you have a condition on the upper respiratory tract. And we're going to treat just that. Now, upper respiratory tract infections, conditions are a lot easier to treat versus the lower part. See, know these terms, pharynx or throat, larynx or the voice box, because they're going to ask you. The larynx is also known as, the voice box. The pharynx is known as the throat, but they can invert the question. The throat is also known as the pharynx, and the voice box is known as the larynx. Not the pharynx, the larynx is the voice box. So that's very important. Well, fortunately, the nose doesn't have any other terms that we have to know or learn. The upper part, well, the upper part is there. If I separate the upper part, I know what the lower part is going to be. So the lower part is going to be the trachea, which is this tube right here. Then the bronchioles, which is this big branch right here, right and left. And then the little branches from the small branch, which are called the bronchioles. And then little sacs like these ones that you see at the end of the bronchioles that are called the air sacs or the alveoli. So it looks like a tree. See? The trachea, the trunk, then big branches, then small branches. And at the end of these small branches, we're going to have flowers of fruits. That's it. That's the end. That's what it's talking about. And then the lungs, which covers, within cases, all these internal structures, the lungs. So we're going to have the trachea or windpipe. Be careful with this. Questions for exam. Remember, pharynx, the throat, larynx, the voice box, the trachea, or windpipe. The bronchial tree is the bronchi. Bronchi means, once again, two, more than one, because we have right and left, the right lung and the left lung. These are the paths or the pathways that bring oxygen from the trachea to the lungs. But then it becomes in small branches, the bronchioles on each side. And then the alveoli or air sacs. Very important, air sacs, alveoli. Because this is the place where gas exchange takes place. The alveoli or air sacs, this is the place when air exchange happens. It's not in the trachea, it's not in the bronchioles, it's not in the bronchi, it's not on the larynx, no. The gas exchange happens at the end of all these respiratory structures that is called the alveoli. So again, later on, we're going to see how that gas exchange is going to move from the blood to the lungs or to the alveoli and to the alveoli to the blood and out, in and out of our body, how that works. Because that's how important it is to know how this functions. It's like how blood enters the heart, how blood moves or flows within the heart, and how the blood is pumped outside through which structures. So here we're gonna see how the air enters and exactly where are we gonna do this gas exchange. Because remember, everything else within the respiratory system, they are tracks. Everything are tracks, tracks. The only one that is not a track is this one. And of course, this membrane that protects all these internal structures. But here, the most important thing is going to be, for now, for the gas exchange, it's going to be the alveoli. And because it's so important, you need to know it for exams. So they're going to ask you where within the respiratory system gas exchange takes place, the alveoli. If you don't see alveoli, you should be looking for air sacs. What type of gases are we exchanging at the alveoli or air sacs? Oxygen goes into the alveoli to the blood, and carbon dioxide comes from the blood to the alveoli. That's how it works. We will discuss this in a little bit, because you need to understand how this works, how oxygen enters. So that will be this. So remember the lungs, we're going to discuss this in a little bit. The lungs have the body, the human body has two lungs, one on the right, one on the left, two lungs. Then we will describe the structures of the lungs and every other structure. We're going to talk the basics. We're going to describe the basics of each one of these structures. So that's what we're going to do when we come back from break. So for now, it's going to be 7. Let's take a break before we start, because I don't want to leave something in the middle or be running. So let's take a break. This has been a lot to digest. So we're going to go it's 7. We'll come back at 7:25. Okay. Have like 3 minutes before 7. So 7:25, we're gonna come. Let's do 7:30, because sometimes 7:25 minutes goes too fast for you guys, not able to eat anything, to prepare anything. 7:30, we come back, okay? If you're not agree, let me know. If you want only 10 minutes or no break, let me know. Listen, I'm no live, so.
7:30.
All right,
Thank
guys.
you.
All right, 7:30. See you back. Take care, guys. Enjoy. Okay, so we are back. We're going to continue with the chapter where we left off. I hope you guys enjoy your break. Okay, so a little recap. We are working on the respiratory system. So we know that the respiratory system has to do with taking air in, delivering oxygen inside the lungs, and removing carbon dioxide when we breathe out. So we talk about these structures that makes up the upper respiratory system and the lower respiratory system. We have to have these two divisions separated because upper respiratory structures can cause certain type of conditions, and the lower respiratory tract can cause other respiratory conditions. Upper respiratory conditions are not as serious as lower respiratory conditions. Usually, when we have problems with the lungs, with the alveoli, it is more serious than when we have something within the nose, within the throat, or within the larynx. So it's a lot easier to solve the problems on the upper respiratory system. So we have to make the difference between them. Okay, so let's begin with the nose, because that's the first structure that we use to enter air, right? So that's basically what it is. So the nose, it contains nostrils, which are the external nares. Nares are these openings. Nostrils are these two openings that we have at the beginning of the nose and the little tunnels that follows forward or inside. So these openings not only allows the air to pass through, but these openings are covered with the mucous membrane. And this mucous membrane is moist, meaning it provides like warmth to the air when it comes in. And if it is too hot, it freshens, it cools down the air. Because when we breathe, remember, summertime is very hot, or we are close to the oven or something that is hot. Well, this air is not going to go in the same temperature from the outside to the inside. It's going to burn our structures, the mucous membrane. So this mucous membrane has the function to cool down whatever enters there if it is hot. And if it is cold, like in winter time, this air that is so cold that it burns our nostrils, it just burns our nostrils. But then when it goes inside, it is warm. So that's basically what it does. Now, within this mucous membrane, within this cavity of the nostrils, we have some little hairs, some internal hairs, some of them that we can see them, and sometimes we have to trim them because each shows right there at the entrance of the nose. But these hairs called cilia are very important because they are the ones that traps all the dust, pollen, some insects. They trap it so they don't allow them to come inside. So that's basically what it is. So we have some functions within the nose, but most importantly is the passage of air through these openings. That's basically what it is. That will be the nose. Now let's talk about the pharynx. Now here is the nose, right there. This is the passage. So everything that we breathe goes to these nostrils right here, and air passes from the outside to the inside, right? This is the air. So here we find the pharynx. Remember, the pharynx or throat is a common structure for air, food, liquids to pass through. So this area is very common for those things. So the nose on top, then it connects with the pharynx, all this structure, until it reaches the larynx. That will be the next structure. So that's basically how this works. So this blue or something that looks like blue is the pharynx. Remember, pharynx is known as the throat. So air comes from the outside, enters through these tunnels and the nostrils, then it meets with the other track, which is the pharynx. And then remember, these are just passageways. Only air can pass through there, but the pharynx has more functions because it connects with the mouth. So because it connects with the mouth, you see right here, the mouth is going to end up right here in the pharynx. The nose end up in the pharynx. And now at the end of the pharynx is going to connect with the larynx, which is the voice box. So these are passageways only. So air is passing through all these structures. Moving on, the larynx or the voice box. So that will be located right here by the neck, in the front of the neck. For males, sometimes you see a little some protuberance coming out of the neck. Females usually don't have it. But once again, you have the larynx. It's not that it's pronounced as in males. So that's basically what it is. So this is the structure that connects the pharynx with the trachea. So on top, we have the pharynx. So here is the pharynx that is connected. And this is the larynx, the whole thing, up to here. And this is the trachea that is connected on the bottom part. So because we have all these structures connected to each other, like a chain, all these links, so allows the air to pass through all these structures to the very deep part of the lungs. But before we reach the trachea, we're going to talk about certain structures that are found within the larynx. So remember, the larynx moves air in and out of the trachea. So this is the trachea. When we breathe in, air goes in. When we breathe out, air goes out. So all these are just passageway of air, all these structures. So the only structure that is not a passageway, which is the gas exchange, those will be the alveoli or air sacs. Now, the larynx contains the vocal cords. That's what is called the voice box. So these cords right here within the larynx, they are vibrating when the air passes through. Cover your mouth and your nose. You're not going to be able to speak. There is no words that are going to come out if you have problems with your larynx. Think about this. Sometimes we feel like this type of inflammation inside the larynx and our voice is not coming out. or it is very hoarse. So that is because these vocal cords are injured, they are swollen. So if they are swollen, they're not going to vibrate, they are too heavy to vibrate. And the vibration of these vocal cords inside the larynx are the ones that produces the sound when we talk or when we sing or when we produce any sounds through the mouth. So that's basically what it is. So that is the larynx. Now, right there on top of the larynx, we're going to have the glottis. What is the glottis? It is the opening of the larynx. So right here, where the throat or the pharynx connects with the larynx is called the glottis. So the opening of the larynx right here, it is the glottis. Now, it contains also something that is called epiglottis. So glottis, epiglottis. What is epiglottis? So glottis is the opening, epi is something that is above. So here, above this, we're gonna have something that looks like this. And what is? This is the epiglottis. And what it does, when we are eating, here we have the pharynx or the throat, food enter here, liquids, but they should not go into the lungs. So this lid of the glottis, the epiglottis, closes and don't allow food to enter the respiratory tract. So the food will be diverted right here to the esophagus. That's what it is. So it is very important, these epiglottis right here. It is a lid, it's like a little door that opens when we are talking because sounds needs to get off of the larynx. But when we eating or drinking, then this closes. So food goes directly into the esophagus that goes on the back of the larynx and the trachea. So that is the importance of these structures. So having happened to you that sometimes you eating something, but you talking at the same time, what happens sometimes? You choke, you start like coughing, and food comes through your nose, through your mouth. Well, a mess. And sometimes you have to stop eating and of course talking. Sometimes you have to drink something to kind of remove whatever went to the wrong way. Because what happened is something went to the wrong way. Because you were supposed to be eating, not talking and eating, because your brain doesn't understand. Oh, I'm talking and eating at the same time. Your brain doesn't understand. So this lid is like this, opening and closing it, opening and closing it, open, because you're eating and talking. And things can go through here, and that's what makes you cough or choke. Not good. So this is the epiglottis. This is a lid-like structure that opens and closes. Opens when we are breathing, so air can passes through, or closes when we are eating or drinking, so things do not go into the respiratory system. That's basically what it means, all that. So I explain it in my own words so you can understand this better. Don't worry about any other structures Oh, this is the cartilage, epiglottic cartilage. This is the thyroid cartilage. This is the cricoid cartilage. Oh, and yada, yada, yada. No worries about that. You only need to know that this is one structure that contains the vocal cords, the larynx, that is also known as the voice box. For that reason, this is the part where we produce the sound so we can talk. So that is the importance. They're not going to ask you about anything else, which is the structure that is known as the voice box. That's it, the larynx. The larynx is also known as the voice box. That is it. That is it for the larynx. Very basic. Here it is the larynx. Now remember, here we have the pharynx, whole thing right here. Here we have the nose cavity, the nostrils. Now we have here the larynx. So if you see here, I'm going to draw. I'm gonna do it with red so we can see it better. So here is the epiglottis. See this little lid-like structure. And here is the entrance of the pharynx. So when air comes in, all this air start coming in through all these structures from the nostrils, through the pharynx or throat. Now this lid is gonna open up. It's gonna go right here. So air can go right directly into the epiglottis. When we eating, something comes right here through the mouth. The pharynx is a common place for food, air, drinks. So then this lid closes, so it closes the entrance of the epiglottis of the larynx. So food passes on the back because that's when we have the esophagus right here. So food will go directly to the esophagus, not to the respiratory tract. Interesting. So that is the functions of the epiglottis, but within the pharynx. So here we have the epiglottis. You see this little lid look like structure, like a little door, just like a lid, like a can when we open the lid of the can and then we put it back. So this is the epiglottis. So very, very important structure. Without this structure, then, or covers the entire larynx and we're not going to be able to pass air to the lungs, or it's going to be open and food is going to start entering the respiratory system. So that will kill us because food should not go into the respiratory system. So not good. So very important, all the structures. So we are putting all the structures together so you can understand what we're talking about as we move through these chapters. Okay, the trachea. Now, the trachea is this tube. See, here it ends the larynx. Now we have the trachea, all this tract up to here. And it has some rings right here. Some rings that has a C shape, the letter C. It says right here, it's a flexible cylindrical tube. No worries about the length. No worries about cylindrical tube. This is a passageway for air. That's all it matters. So it extends from the anterior part of the esophagus. We're not caring about the esophagus right now, but it connects the larynx to the branches that enters each lung, which is called the bronchioles or the bronchi. So that's basically what it is. So it contains 20 C-shaped rings. So these rings are like this. So let's look at the trachea right here. The rings go like a C shape, but they don't go around the entire trachea. They just do like a letter C. The letter C. They are not rings completely surrounding the trachea. No, it has to leave an opening right here. So when we eat something, this trachea stretches. It becomes wider. And with not eating or drinking, they become narrower. So that's basically what it is. So it is very important that we have these rings. So this trachea has the rings. Later on, we're going to talk about other structures that has these rings as well, and which do not have these rings or see or the shape C's surrounding of the cylinder or these tracks. Remember that the trachea is known as the windpipe. Questions for exam. The trachea is also known as the windpipe. The windpipe is known as the trachea. Remember, the voice box is known as the larynx. Be careful, it's not the pharynx, it is the larynx. And the pharynx is known as the throat. So that's what I want you to remember. The big picture. Next, this is the trachea. So if you see, these are the rings that goes like this. They do not close on the back. Remember, all of these rings, they just go like this. That's what is the C shape. Because when we pass food, remember, and sometimes we eat a large piece of something or a bowl of something, because in the mouth, the food becomes a mass, like a ball. So when it passes through our structures, this stretches. But if it were a closed ring, you will choke with something, and that stuff will stay right there in your trachea. No, it stretches, so allows all this food to pass with no trouble. So that's basically what it is with the trachea. So just know that it's made of some C-shaped rings. They are not completely closed up around the trachea, because it has to give that flexibility. Here is the trachea. Now we have the trachea and its components. So here is the trachea, this tube that connects the larynx right here, the pharynx right here, and then whether the nose or whether the mouth. Now this trachea branches off to the right, inside the right lung, because this is the right lung, and to the left, because this is the left lung. Each structure that branches off from the trachea is called the bronchi. That is plural, because we have two lungs, we have two branches of the trachea going to each lung. We have the right, which is this one, the right, we don't say the right bronchi, we say the right bronchus because it's singular. Bronchus is singular, bronchi is plural. And the left bronchi, or bronchus, my bad. So that's how it is. So these are branches of the trachea. And because they are branches of the trachea, they contain the C rings as well. So the C rings are only present within the trachea and the bronchi, the right and left bronchus. That's basically what it is. These are the tubes, the pathways, the pipes, if you will, that brings oxygen to the lungs. Bronchi and bronchioles. These are the structures that we saw before. So the bronchi, remember, plural, bronchioles, plural, bronchiole, singular, bronchus, singular. Trachea branches into right and left bronchi. There are two. Now here it says in singular, each bronchus branches into smaller tubes called bronchioles. So that's what is called the respiratory tree, because it looks like it is a trunk and then branches and more branches and more branches. And then at the end of these branches, we're going to have the alveoli or air sacs. Yeah. They are microscopic. All of these, see, these structures act as a passageway for air. That's it. From and to the alveoli. Now, the alveoli is not a passageway. This is where actually the gas exchange takes place. So don't mix them up. So all these tubes from the nose, the pharynx, the larynx, the trachea, the bronchi, or the right bronchus, the left bronchus, and the bronchioles, all of them are passageway tubes, pipes that transport air from the outside to the inside of the lungs and from the inside of the lungs to the outside. Remember that the air that we take, that air doesn't go inside, only comes from all these tubes and it drops the oxygen within the alveoli and then takes the air back again outside when we breathe out with the carbon dioxide. Think about the train. The train runs through all these tracks, picking all the people on each of these stations, and then they drop them off to their destination, wherever they're going to go, right? And they come back again to the point of where they started. So this is what happened right here with the air. The air enters from the outside through all these channels, goes to the alveoli, drops there the oxygen, picks up carbon dioxide, and leaves. So when we breathe in, air goes in with oxygen. We bring it to the alveoli. Now when we breathe out, the air goes out again. The air that enters is not staying inside the lungs. Breathe in and hold it. For how long you gonna hold it? Not for much long. So that air needs to go out. The air is just whatever is needed, that media that needs to be bringing the oxygen, because we cannot separate the oxygen outside. Okay, I'm gonna breathe oxygen only. Oops, I'm gonna catch oxygen right here, oxygen right there. That's impossible, right? When we breathe air And within the air, we have a lot of bunch of stuff. But the only thing that we're going to live inside, we're going to deliver inside is the oxygen because it's the only thing that is going to be captured inside. And then this air is going to bring the carbon dioxide to the outside. So that's how it works. Any questions about the trachea, the bronchi, the bronchi, or the bronchioles, or the alveoli? We're going to talk about the alveoli because it's one of the most important structures because that's where gas exchange takes place. Now, everything is important because if any of the tracks that brings the air inside is damaged, no air is going to go in. If the tracks of the train are damaged or there is an obstruction to the tracks, the train is not going to be moving forward. So all this is important. But the alveoli has a crucial job to do, which is the gas exchange. Because air can go inside the lungs, but if the alveoli are damaged with a condition, then it's not going to be able to do the gas exchange. So each structure is important within everything. You have a car, but there are no roads where to drive your car. Well, what is the point of having a car, right? So we need everything. We need the roads, we need the car, we need you to know how to drive a car that is functioning correctly, properly, if you will. So very important that all this information that we have, that all these structures are functioning normally. Because if it doesn't, then we're going to have medical conditions. We're going to have problems accomplishing this particular function. So this is the alveoli. Now, if you look here, this is, let's say that these are the bronchioles, because they are the smaller branches. So these are the bronchioles. And at the end of the bronchioles, you have all these clusters, looks like grapes. They are clusters, they are open inside. So the air comes from the mouth to the throat, to the larynx, through the trachea, through the bronchi, through the bronchioles. Now it enters the alveoli. So the air is here. Now, if you look on the other side of this, we're going to see right here that this alveoli is entangled with blood vessels. We have blood vessels all over these tiny membranes because these are microscopic. Here we have veins and arteries. See, you have veins and arteries. Because we need how the blood is going to be, the blood is the one that is going to pick up oxygen and is going to drop carbon dioxide through these membranes. So that's basically how it is. So all the air that enters around here goes right inside here and it's going to leave O2. And it's going to pick CO2. CO2 is here. O2 is here. So it's going to drop O2 and it's going to pick CO2 and it's going to take it out. So that's basically what it is. So these tiny blood vessels right here, arteries, arterioles, capillaries, they are the one who brings the carbon dioxide inside here. And the oxygen is going to be right in this sac and it's going to go to the membrane of the sac to the blood vessels. Remember, all this is covered of blood vessels. So that's basically how it goes. And this is called the alveoli, where gas exchange takes place. So that is the most important thing with the alveoli. Remember, the alveoli are not passageways of air or anything else. This is where actually oxygen is delivered and carbon dioxide is going to be picked up to be removed. That's how it works. Let's see the process of diffusion, because this oxygen is going to move. Remember, we talked about diffusion during the cell process, active transport, that it needs energy, and it's one of those processes. Oh, my bad. It is passive transport, which is diffusion, one of them. So this is the alveoli right here. This is made very huge, it's big. They make it very big right here. So now you can see. So air enters here to these little balloons, these little sacs. See, air enters here. But what air has within? Oxygen. Oxygen. Because oxygen is coming from the outside to the inside. Now, what do we have here? Here we have these blood vessels. These are the capillaries. And these blue ones are the venules. See, capillaries and venules. So the venules, because it brings the blood that is dirty, has carbon dioxide. So see, from the venules, carbon dioxide moves inside the membrane through the alveoli. Oxygen moves out to the blood vessel through the process of diffusion. See, it diffuses during gas exchange. Oxygen diffuses through the alveolar walls of membrane and enters the bloodstream. So that's how it works. So this oxygen that enters these sacs this air contains oxygen, but the oxygen needs to go into the blood. So it's gonna go right here to the blood. From here, from the air goes to the blood. From the air goes to the blood. From the air, oxygen goes to the blood. And carbon dioxide that it is within the blood goes right here inside the alveoli. So now when I breathe out, this carbon dioxide is going to be removed. Why it's not going to remove the oxygen? Because the oxygen went inside the blood vessels. So that is gas exchange. That's the process of gas exchange. Any questions about gas exchange? So now you don't need to know the process, how this oxygen moves out or enters the bloodstream and how carbon dioxide moves from the bloodstream to the alveoli. No, but you need to know that this is the gas exchange process within the alveoli. So remember, oxygen goes from this alveoli or this air sacs goes into the bloodstream, and carbon dioxide that goes from the blood to the air sacs. Because the blood is the one that brings the carbon dioxide, the wastes. We have to remove it. So when we breathe out, we remove carbon dioxide. So that's what you need to understand. But once again, this is for you to understand so you can see what do you mean? How is gas exchanged within the alveoli? I don't get it. Well, in simple words, I already explained it to you. Oxygen comes right here because this is the last structure of all the structures of the respiratory system inside the lungs. So let's say that you go from your home to your workplace. So you pass through all these stations, but that's not your station, so you don't get off. You go to the last station, and it is the last station of the train. So then the train needs to go back. But you're not coming back with the train. You just get off from the train, not gonna get home again. So who's gonna get home? Well, someone else is gonna get home because he needs to return back to home. So you take the train to your workplace, and then when you finish, you take the train from your workplace to your home. It's not the same. Going to work is not the same than going back home. That's not the same. So entering air and removing air is not the same. Delivering oxygen and removing carbon dioxide is not the same. Even though if it goes in the same track, but they go in opposite directions. One enters, the other one leaves. That's gas exchange right there. Any questions? I hope that I make it simple for you guys to understand. You don't need to know these for exams, but I do want you to understand how these gases exchange inside our lungs. Now think about this membrane right here that allows the diffusion of oxygen to go inside the blood vessels from the inside to the blood vessels, and the carbon dioxide to go inside is damaged, is swollen, is too thick, doesn't allow either or pass or enter. Well, we're gonna have problems because oxygen is not going to go inside the blood system, and carbon dioxide is not going to be able to be removed from the blood system. So now we are in deep trouble. So now we're having problems breathing. Now we're breathing faster. Now we can actually collapse. Now we are very weak. We can't do anything because we don't have oxygen. So very, very important process right here. Okay, let's move on. If you have no questions, let's move on. Let's talk about the lungs. So as I mentioned before, we have two lungs. One on the right, one on the left. And remember, just like when we talk about the heart, these lungs are separated right here by the mediastinum, right here. Mediastinum means middle or the sternum. So that's basically what it is. So they are separated. One goes to the left and one goes to the right. So very important thing to know that not that these lungs, see, these are like little balloons, right? So the walls of the lungs are very thin because they have to have the capability of expanding when we breathe in and contracting when we breathe out. So they have to have that flexibility. So if they become thicker, if they become swollen, the walls, they're not gonna be able to expand and contract. We wouldn't be able to breathe normally. Now, let's talk about the right lung. The right lung has three lobes, three compartments, three rooms, if you will. So we're gonna have one right here, lobe, upper lobe one. Then we're gonna have one right here. This is the middle one. And then we have a third one right here. Whereas the left lung only have two. This one right here and this one right here. Why do we have two lobes within the left side of the lungs? Because the heart is occupying space right here. See? The heart is occupying this space. So for that reason, we have three lobes on the right side and two within the left side. Remember, the left side is when we have the lungs. Oh, the heart, I'm sorry. So this is important. So questions for exam. The right side, the left side of the lungs have how many lobes? Two. The right side of the lungs, how many lobes have? Three. The lungs are located within the chest cavity, see? Just like the heart is. So remember the diaphragm, this muscle of respiration is located right here because it assists with respiration. You're gonna see it later on. So that is how we are going to remember the lungs. Forget about whether it is the membrane is flexible, not flexible. Know how many lungs? Two. How many lobes each one of these lungs has? The right has three, the left has two. What is the reason why the left has two? Because the heart is occupying space on the left side. And this membrane protects all these internal structures, the bronchi, the bronchioles, and the alveoli. Any questions about the lungs? So here we have the lungs. So we're gonna have here the right lung. Remember, anything that is facing you is the opposite of you. So this is the right lung, and this is the left lung, see? And this is the right, and this is the left. And this is the structures. This is a cadaver. So that's how we see these structures in this way. Now we're gonna see these lobes and other structures that separates these lobes within each lung. See, this is the superior lobe. This is the middle lobe. And this is the inferior lobe. Remember, we're talking about the right lobe. The right lung, my sorry. Now, there is a membrane that separates these lobes. So the one that separates the lungs right here, the upper from the middle, is called the horizontal fissure. It is this one, see? The horizontal fissure, because it separates this superior lobe from the middle lobe. So this part right here. And the other one is the oblique fissure because it goes in a diagonal. That's oblique, which is this one. separates, once again, the middle, which is here, from the lower. Now, probably you're not going to be asked about these features, but again, it's important for you to understand that we have lots of structures within organs, little tiny structures. Sometimes, they have their own function. It's like when we divide the body in quadrants or in regions. Why? Because we need to separate certain organs from this region, from this region, from this region. It is a lot easier for us to know what is it, what we find within these particular regions. Think about New York City is divided in boroughs. Why is that? Can you imagine everything is New York City, the entire city? It would be difficult. No, we have Manhattan, Bronx, Brooklyn, Staten Island, Queens. So it's a lot easier to find the address. Oh, I live in Queens. Immediately, I focus myself in this area. I live in the Bronx. I live in Manhattan. I live in Brooklyn, Staten Island. And what divides each region, each borough. So that's important. And how do we get there? Which modes of transportation we use? What is the function of each one of these regions? So that is important. That's where we break down everything so we know exactly with more details what is this structure, what it does, where it's located. Any questions about the right lung? Because now we're going to move to the left lung, which is very similar, but it's located on the left side with one difference. It doesn't have 3 lobes, it has 2. It doesn't have 2 features, it has 1. Here it is, the left lung. So we have the left lung right here. The superior lobe. Then we have the inferior lobe. But this fissure or this membrane that separates the superior from the inferior is called the horizontal. We don't have the oblique because we have only 2. So that's exactly how this works. So it will be the horizontal because we have 2. So the most important thing right here, the basic part, the take-home point for this lecture or for this part of this slide is that the lungs, we have 2 lungs, one right, one left, that the right lung has 3 lobes and the left lung has 2. That's it. That's all you need to know about the lungs. So that will be it. I mean, that's all you need. That's the basics. Moving on, let's talk about now the membrane that makes up the lungs. Because remember, that's the membrane that inflates and deflates, expands and contracts. So let's talk about the membrane, and then we're going to talk about other structures, which is the halo. So we leave it for last. So first, let's focus on the membrane itself. Remember, this is a membrane that is very flexible. It has to have the capacity to inflate and deflate. That's basically what it is. So it's going to allow air to enter and deliver the oxygen, and then on its way out, air is going to take within carbon dioxide. So that's basically what I want you to know. Not all the specifics, remember. We're going to forget about all these specific details, technical terms, because then it's going to be a little harsh to remember. Just know this is like a little balloon that you inflate and you can remove the air. You can put air or you can remove the air. That's basically what's going on right here. So the lungs, this membrane that makes the lungs, is made of two tiny layers, the parietal and the visceral pleura. Pleura means lungs. So we have here the parietal pleura and the visceral pleura. Parietal, outer layer, visceral, inner layer. Do you remember the membrane that was protecting the heart? Well, it has the same, it is very similar because it's a membrane. And it has the parietals on the outside and the visceral in the inside. So that is the pericardium, remember? The pericardium membrane or the pericardium membrane. Now, in between these two layers, we are going to have right here in between, we're going to have fluid. We're going to have the pleural cavity, which contains the pleural liquid. So it is the pleural cavity, which is in between the parietal and the visceral pleura. Remember, that's what I draw this line right here. So in between these two layers, we're going to have fluids right there. The pleural cavity and the pleural fluid. See, this is the pleural fluid right there. And what is the function of this pleural fluid? Well, allows the lungs to flexibly expand and contract. And when they expand, they hit some other organs like the lungs or like the heart, they're not going to get injured because this is a very tiny membrane. And if you are poking, so to speak, when you kind of inflate against the heart that is beating, then you don't want your membranes, whether the pericardium or the pleural membrane, to become bruised or injured. So this is like a cautioning mechanism of protection. So that's how it works. Now, you are not going to be asked about the pleural cavity and the liquid inside or anything like that, but you have an idea how this actually works. So we're going to see this, how looks like, how the lungs looks like in a complete diagram. And then we're going to mention the hilum, which is this one, because the hilum is the place where the trachea connects with the lungs. So we're going to see it right here. This is the hilum. Right here, where the trachea, the bronchi enters both of the lungs. That's called the hilum. Now you see the lungs. Now you see these membranes. See, this is the parietal pleura. So it's one layer on the outside, and then in the inside, you have another layer. So let's draw this. Let's put it like this is one layer. Now we have another layer. I'm just making it big so you can understand how it works. And right inside this is the visceral pleura, the one inside. The one outside is this, and the one inside is this. And now in the middle, right here, we're gonna have the pleural fluid. See, the pleural fluid. That's what makes like this membrane to be soft, to be kind of moist, so it doesn't dry off. Because remember, these lungs, we using it just like the heart is beating at least 60 to 100 beats per minute. Every single second we have a beat is contracting. Can you imagine the lungs are doing the same? We are breathing in and out. Every single minute we have between 12 to 20 breaths per minute. Whether we are sleeping or doing something, well, if you're doing an activity, you are breathing faster. So we are taking air faster and more air because we are using more oxygen when we are active. But even though if we are sleeping, we're going to be using oxygen every single time we need oxygen. Oh, oxygen, none of these organs are going to shut down just because we go sleep. Even our brain continues working because you have dreams. So everything moves all the time. So it protects when the heart beats and it hits this membrane because the membrane is so tiny, so thin, well, it's not going to be damaging the lungs. When we run, when we hit something, when somebody hit us in the chest, it's not going to break this because it has this cushioning right there to protect us, not to mention the rib cage, right, on the chest. So that is the pleural membrane with these two layers, the parietal and the visceral, plus the pleural fluid inside. So that is what is depicted right here in these pictures. So we can see the lungs, which each one of these membranes, and it says right here, the pleural cavity, because it's this part that they make it a little wider. So where all these liquid runs underneath in between these two layers. So that's how these membranes are, made of. Any questions about the pleural membrane? Remember, pleural means lungs. Cardium means heart. Now let's talk a little bit about the diaphragm. Remember, I mentioned the diaphragm prior. First of all, you need to know that the diaphragm is the muscle of respiration. Do not forget that. This is asked on national exam. So the diaphragm, very important. So 3 questions that might arise during exams. Which the following is known as the muscle of respiration? The diaphragm. Where is the diaphragm located? The diaphragm is located in between the thoracic and the abdominal cavity. Because if you see right here, see, these are the lungs. But then right here is going to be the diaphragm, which is right here. See, these are the lungs. And the diaphragm is here. So when we breathe profusely means that you take a force air inside. So we breathe. our chest expands because our lungs fills in with air, both of them at the same time. So they inflate, they become really large. So what happens is when they become really large, what happened to the diaphragm? The diaphragm is sent back, is sent down and becomes flat. So the diaphragm is that's what is called the muscle of respiration. Because when we take air in forcefully, then the lungs becomes full with air and pushes this membrane. Because even though if it says the muscle respiration, it's a very thin muscle. So it pushes this muscle down. So the lungs can expand. When we breathe out, this muscle goes back again to its normal round shape. Because pressure increases here when I breathe in, pushes the diaphragm down. When I breathe out, pressure within the abdominal area increases, so it forces the air to go up because it pushes the diaphragm up. That's how it works. So when I breathe in, pay attention to this. When I breathe in, what is the pressure inside the lungs? Positive or negative? Well, when I breathe in, the positive within the lungs needs to be negative. Because if I have positive pressure, air cannot go in. So pressure within the lungs when I breathe in needs to be negative. Because if it's not negative, air cannot go in because this will be pushing the air out. So it has to be negative. The opposite is also true. When I'm breathing out, what is the pressure within the lungs? It has to be positive because it has to push the air out. So that is something that, you gotta keep it in mind. Because how is the air gonna go in? Think about you have 10 people inside your room holding the door and you are trying to push the door open. Can you do it? I don't think so. There are 10 people pushing the door and you are trying to open that door from the outside. But in the inside, there are 10 people over there. How can you find all these people? So in order for you to open the door, it's got to be less pressure inside so you can enter. So in order for you to pass air into your lungs do not have to have pressure, has to have a negative pressure. Nobody pressure anything. Nobody kind of forcing you not to come in. But when you're gonna get out, oh wow, the more people that are pushing you out, the fastest that you go out, right? One person probably is gonna be difficult to throw you out. But if there are 5, 6, 10 people, oh wow, they're gonna throw out in a blink. So that's how air comes in and out. Remember, that's the diaphragm. The diaphragm is a very, very important muscle. Now, just something so you understand how important the diaphragm is. Let's say that a patient goes into a surgical procedure. This patient receives general anesthesia. What is general anesthesia? Then the patient is knocked down completely. The patient doesn't know what's going on. The patient is put on oxygen. Now, patient have anesthesia, not local, general anesthesia. They do the surgical procedure anywhere in the body, in the heart, the liver, the kidney, the intestines. They did something. Now, the patient is going to recover, right? After the surgical procedure, the patient comes out from anesthesia and everything went. What happens if this patient does not wake up? Well, it's not that the surgical procedure went wrong. It's because this muscle was received too much anesthesia. Now it's paralyzed. It's not waking up. And I already removed all these tubes that brings oxygen to you. Oh, you're in big trouble. Because this patient, if it's not treated immediately, putting the tubes with oxygen again until this muscle regains its function, then the patient is going to die. Have you heard patients dying after surgical procedure? Not because of the surgical procedure. They die mostly because of too much anesthesia. That's why anesthesiologist needs to be specialists on this. It's not just anyone that can be anesthesiologist, because the anesthesiologists have the responsibility of administering anesthesia to the patient, but certain amount, and they have to be there injecting a little more if it is needed, but you cannot put too much anesthesia. So you have to be monitoring your patient. That's all you do. An anesthesiologist doesn't do anything else. You sit in front of the screen like I'm doing, watching the patient on the screen, how it breathes and relaxes. When the patient starts moving, oh, the patient is waking up, let's put a little more anesthesia. That's what we do as anesthesiologists, nothing else. And if something happens, it was your fault, you're responsible for it. Not the person who did the surgical procedure, not the surgical surgeon. It will be you, the anesthesiologist. They make a lot of money, but they are the most sued people in the medical field. So once again, you see how important it is, this muscle. That's what's called the muscle of respiration. I just gave you that so you understand how important it is, this diaphragm. And with the story that I already told you, you're not going to forget about the diaphragm. Okay. Any questions about the diaphragm? What do you mean no? Wow, guys, or learning too much, or you just don't want to bother me? Well, we'll see. The diaphragm, here it is. Once again, very important. Here we have this is a cadaver right here on this side. A, B is a chest x-rays. That's basically what it is. So now when you see the lungs, because this is important, that's why we have this picture right here. It's not just for you to see, oh, how nice the lungs look, and then an x-ray. No. That's not what it's the whole about. This is what's important. Air inside the lungs on an x-ray image looks dark. Pay attention to that. Air on an x-ray, when you have the lungs, you have the chest x-rays. We are taking a picture of the lungs with x-rays. The air inside the lungs looks dark, just the way it looks right here. See, it looks dark. That's air. Why did I write down airs? Air looks dark. Pay attention. Any other structures that is not air, that are solids, they're gonna look light. They're gonna look white. See, right here, we can see the ribs going around because it goes through the ribs. We see we see right here the bronchi, the bronchioles. See the branches? The branches can be seen right here. So they look white. So think about this because these are questions for exam. How does the air looks inside the lungs on an X-ray? Dark. Dark. Any other structures that are solids, like veins, like bones, they are going to look white. So that's something that you need to understand. That's what I have this picture right here. Because these are questions for exams. Okay. Any questions? So why do we do X-rays to your lungs? Well, because we are suspecting that something is wrong because you are complaining about coughing, not being able to breathe normally. You probably have fever. You probably were to a tropical country. Probably you got bitten by a mosquito. Probably you have malaria. Probably you have tuberculosis. Probably you have COVID. You just have the flu. Probably you have some infiltrations. Probably you have a mass there. Probably you have a tumor. Well, yes. If we see a mass right here, a tumor, cancer in other words, so then we are going to see these white patches. Then we will see a mass or some infiltration. We will see it right there. So it's not dark. And it doesn't look like a blood vessel. It doesn't look like it's a rib because of the shape. We see a mass right there. Then we know exactly whether it's in the superior, middle, or inferior lobe. So that's how we know. That's what we do X-rays to see if there is some changes because this is supposed to look dark, but now we see some masses, some patches right there that looks different color. So now we know, oh, wait a minute, something is not right. So don't forget that air inside the lungs looks dark in any other structure, solid structure like bones, like blood vessels, they're gonna look white or gray, just gray for that matter. So that's basically what it is. If you don't see kind of dark, well, look for gray, but it's darker than just clear. Any questions? So conditions that happens to the lower part. Let's talk about the lower part because the lower part is the most serious. Well, we can have cancer of the lungs. We can have tuberculosis, is on the lower part. Think about these conditions. Tuberculosis happens to the lower part of the lungs, meaning inside the lungs. Cancer inside the lungs. COPD inside the lungs. Asthma has to do inside the lungs. So these are the most common conditions that we might encounter with the lungs. So remember, cancer being one of the worst, COPD, asthma, tuberculosis. Now, of course, COVID, because it's recent condition, recent addition to the conditions that can happen to the lungs. The upper part, simple, because it's the throat, sore throat. upper respiratory infections, the flu. It's just your throat, it's just your nose, is it within your larynx? You can't talk, it is your larynx. You have a hoarse voice, it is your larynx. Your runny nose, itchy eyes, that's the upper part. So that's how we are going to understand the respiratory system. Remember that the patients are going to come complaining because this is applicable to medicine. We don't cover this anatomy and physiology just because there's nothing else to do, right? Because this is going to be applicable to whatever job we're going to do. Of course, our level as a medical assistants. But you're going to have, listen up, you're going to have 50, 60% of the population coming to your office complaining about upper or lower respiratory conditions. How many asthmatic people do we have? Lots. How many people develop the flu? Many. How many people have allergies? Many. So knowing the difference between someone who's been diagnosed with tuberculosis, cancer of the lungs, is totally different. Somebody says, oh, you had the flu. Oh, that is nothing. But if you've been diagnosed with cancer or COVID or some other type of conditions from infections that are serious, COPD due to smoking, well, things are different, right? You see the difference between, having an infection of the upper tract, which is, remember, the nose, the pharynx, and the larynx, versus the lower part of the respiratory system, which is the trachea, the bronchi, the bronchioles. You heard about condition bronchitis, right? Yeah, that's inflammation of the bronchi. These two branches that enters air to the lungs. Very common. Now, the little kids do not develop bronchitis, they develop bronchiolitis, which is the tiny blood, the tiny tubes, the branches off from the bronchioles. Asthma, which is inflammation of these tubes, whether the bronchioles or the bronchi or the bronchioles. So those are lower conditions of the respiratory tract. And we have many of these patients visiting our offices or the hospital. Asthma patients, bronchitis, the flu, and so on and so forth. So for that reason, it's important for us to know and distinguish these parts of the respiratory system so we can kind of, follow. So when someone is complaining about respiratory problems, you already know that the doctor is going to ask you to check the respiratory rate to your patient. We're going to do that. Maybe to do a peak flow, to do an spirometer. So again, or spirometry, which we will learn within these clinical procedures, which is going to be probably the next module. So these chapters are fundamental, are basic for any other material, any other modules that we're going to cover. Because you're going to learn portions right here, portions right here, and then we're going to put it together, and it's going to make sense. Okay. Any questions about the respiratory system? Anything at all? Okay, then So we're gonna leave it here. We're not gonna start a new chapter. We have just a few minutes for it now. So we're gonna relax a little bit. We are going to go eat. We're gonna go get some rest. Tomorrow's another day. You probably have to go work. Well, whatever you have to do. Well, let's just leave it right here. It was a lot of information. Thank you for participating, attending the class. See you tomorrow. Get some rest once again. Anything, any questions, remember, email me.
Thank you so much, Professor.
Oh,
Good night, everyone.
you're welcome, Mercedes. Take care, everyone, too. Good night. Go
Good
get
night,
some
everyone.
rest.
Good night.
Night, teacher.
Good night. Good night. Thank you.